Continuing from our last video, we will cover the standards of 802.11i, 802.11r, 802.11k, 802.11w in this video, right? Okay, so 802.11i is a very, very important standard for us because it defines the security part of the Wi-Fi world. The Wi-Fi transmissions are always susceptible to security. In fact, whether it's wired or Wi-Fi, security is a major concern for us. We want to make sure that networks are secure, data that is sent over the air is taken care of properly, is handled well, and there is no breach in the security as well, right? So, for many years, we had a couple of ways to authenticate clients. We had a couple of ways to encrypt traffic. By the way, security is covered in two aspects. One is authentication of the clients, that is checking the identity of the user. Second is data privacy, which is simply encryption of the traffic. Whenever traffic is exchanged between the user and the AP, it has to be encrypted, right? So these two aspects cover the entire security concepts. Now, for many years, we had a couple of ways of authenticating the users. We used something like open system authentication, which is nothing but anybody could come and access this network regardless of the identity of the user. If you want to connect, come and connect just fine. Open system authentication, which means no authentication. Second was shared key authentication. In this type of authentication, we'll not go in detail, but in shared key authentication, you would define a specific key, a static key, I would say. We would define a static key on both the AP and the client. I think it was a 64-bit static key, which we would define on both the client and the AP, which would be used for their authentication. Now, once the authentication was successful in shared key authentication, that same key is also used for encrypting the traffic, also used for encryption. Now, it's a problem because if this key is compromised, then everything is compromised. The hacker who gets this key will be able to decode and understand whatever is the communication happening between the client and the access point. So these two methods, which were used for a long time, were kind of flawed, not very efficient for us. So, this had to be changed. And also, when we talk about data privacy, we had, one type of encryption that was used, which is web, web encryption, also known as wired equivalent privacy. Wired equivalent privacy. This was the encryption that was used. Not a great method of authenticating or encrypting way back, but then there was a need of a new standard in security because this had to be addressed. Now, this particular standard, which was 802.11i, which was launched, also known as Robust Security Networks, RSN. Now, as the name suggests, it's quite robust and it defines a couple of new ways of authenticating the client, of authentication and encryption or data privacy, right? In authentication, two things came out. One was EAP authentication, extensible authentication protocol. Second is PSK authentication, pre-shared key authentication. We will discuss more about these two authentications, but for now, in of course in future videos, but for now, we'll just stick to this in brief. A couple of encryptions which were also brought in this standard were TKIP, TKIP encryption, and CCMP encryption. Now, CCMP uses the AES algorithm. TKIP uses the RC4 algorithm, which was also used in WEP, that is WEP, the same algorithm, with some enhancements, of course. EAP authentication and PSK authentication were launched in .11i. In encryption, we had TKIP and CCMP encryption using RC4 and AES algorithm, respectively. These two standards, I mean, this .11i standard changed the way we did authentication and data privacy for users, and the wireless networks became a lot more secure than they were, than they were. Okay. The next standard that you want to talk about is .11r. Let me draw a line. 802.11r, also known as fast transition or fast roaming. So just a brief about this standard right now. We're not going to go in detail again. Just in brief, we'll discuss and understand what this .11r standard is. This was ratified in 2008, by the way, not before that. Now, uh, usually when a client does EAP authentication, okay, it takes around 700 milliseconds to finish the authentication. If my client is moving on a voice call from one direction to the other, okay, moving in this direction, and he has to move from one AP to the other AP, he cannot wait for the entire EAP authentication to happen, because if on being on a voice call, they can only handle latency up to 150 millisecond approximately. Now, if the authentication takes more than that, the call will drop, and that's going to be a bad experience on the user. So we came up with a way to make sure the transition between one AP to the other happens smoothly. That is defined by 802.11r standard. Fast transition or fast roaming makes sure it takes care of the fact that a client is handed off to a new AP in the required amount of time, so that the voice call doesn't drop, or so that any data is not dropped, any disruption to services you know doesn't happen. That's .11r for you. This is again just in brief, because .11r is a huge standard. There are a lot of things that we can cover in .11r, but we will cover that in the future, in the future videos. The other standard that I want to discuss about is 802.11k, also known as radio resource management, that is RRM. RRM is quite critical because it defines at what channel and what power level your AP will work. Radio resource management is responsible for calculating the TPC, that is transmit power control of the access point. It does DCA, that is dynamic channel allocation to the APs. Okay. It also gathers the client's statistics and reports it to the AP. Statistics like what is the SNR, signal to noise ratio, what is the signal strength that I see on the client, all these things it will gather and report back to the AP or the controller, anything that is running RRM. It also takes care of, or it also collects the channel stats. on which the AP is working at the moment. Channel stats like what's the noise floor on that channel. Also like what is the channel load information. So these stats are collected and reported back, which helps the controller or the AP to take better decisions and then change the TPC and the DCA of the AP. That is a transmit power or DCA, dynamic channel allocation. .11k takes care of that. Okay. Now the next standard that I want to discuss is 802.11w. That is also called management frame protection. Okay. So in the Wi-Fi world, it is very easy, or it is a very common attack. Uh, it's quite easy for any hacker to get access to a deauth frame or a disassociation frame, and then it is easy for them to edit that frame and then spread that out in the air and shut down the entire Wi-Fi. This is called a denial of DOS attack, denial of service attack, denial of service attack. Okay. For to eliminate this or to prevent this, we do something called MFP. What we do in MFP is we make sure we encrypt the management frames with CCMP encryption. Okay. When we do this, any hacker cannot just capture the frames and decode the management frames. The frames also will be encrypted with AES and CCMP encryption. Hence, it is not easy for them to crack and decode. Hence, we can prevent a DOS attack. Okay. This is .11w, management frame protection, in which we encrypt the management frames to avoid attacks. Then there are more standards, of course. 802.11n, 802.11ac, 802.11ax, also known as Wi-Fi 6. You heard about this? This is called Wi-Fi 5. This is called Wi-Fi 4. I will create a dedicated video for all these standards because this requires us to talk about this in detail. Okay. Anyway, so I hope these standards were clear to you. If not, I want you to go through this video once again because it is essential that we understand what 802.11 A, B, G, R, I, W, K, all these standards are very critical for us to know. So we'll come back in the next video. We'll start a new chapter then. Thank you.